We're going to find the area of the regions enclosed by our two curves given here. Y equals x to the power 4 minus 4x squared plus 4, and y equals x squared. I did a quick sketch, but before we get to the sketch, the black one is the second one, and the orange one is the first one. But let's find these points of intersection. So basically what we're going to do is solve by setting these equal each other. So we have y equals y. So basically you set x to the 4th power minus 4x squared plus 4 equals x squared. And set everything over here on the left-hand side. So you're going to get x to the power 4 minus 5x squared plus 4 equals 0. And when you factor, you're going to get x squared minus 1 times x squared minus 4. Again, this can get factored more. This would be x minus 1, x plus 1, x minus 2, x plus 2, and so forth. Okay. So basically, the curves intersect at plus and minus 1 and plus and minus 2. So let me put that in red. This is where they're intersecting at. This is minus 1, plus 1. This is 2. This is negative 2. And the reason I drew the graph is because we're going to use the fact that it's symmetric to help us find the area. So this is the area, the shaded area I'm about to shade. This is what you want, this area right in here. I know this graph isn't the best, but it kind of gives you an idea. And so I can basically erase this top portion here. So that's what we're looking at. Something like that. Now the reason I wanted to draw it is that since it's symmetric about the y-axis, I'll draw a little line here. What I can do is I can take this area and this area and then just multiply this area by 2 to get this area. Multiply this area by 2 to get this area. Now this first area is going from 0 to 1, and the second area is going from 1 to 2. So that's what we're going to do. So I just wanted to give you a general framework of how I'm going to set this up. So we're going to start with area 1. So basically we're going to multiply it by 2 to get the left-hand side of the axis. And from 0 to 1, you're going to take this curve here, x to the 4th minus 4x squared plus 4, and subtract this one. All right, dx plus the second area. And that one we're going from 1 to 2. And let's start here, x squared minus x to the power 4 minus 4x squared plus 4, and then dx. So simplifying all this, we're going to get 2 times the integral of 0 to 1. And for this piece, we're going to get x to the power 4 minus 5x squared plus 4 dx plus 2. And now we're going from 1 to 2. And this part here is just going to be negative x to the power 4 plus 5x squared minus 4 and dx. All right, let's integrate this. So for this first piece, we're going to get 2 times 1/5 x to the power of 5 minus 5x cubed, divide by that 3, plus 4x, and we're going from 0 to 1, plus 2 times negative 1/5 x to the power of 5. It's the same thing we got before, but the signs are different. 5 divided by 3, x cubed, minus 4x, and now we're going from 1 to 2. So let's evaluate this now. And we are going to get 2. So if you substitute in 0, it goes away. So we only have to do the 1 here. So this is going to be 1/5 minus 5/3 plus 4. So that's this one. This one, we have to do both of those. So this is going to be plus 2. And then we're going to get negative 32 divided by 5 to 2 to the 5th power there. Plus 40 divided by 3 minus 8. Then we're going to have minus negative 1/5 plus 5/3 minus 4. All right. Now simplifying all this, you can simplify. You can actually pull out the 2 and simplify all this, but just use your calculator, and you are going to get the area equals 8. And that's it. Thank you. Have a nice day. Bye-bye.